Hello everyone, in this video let us solve this question together. So we have t raised to power t is equal to t raised to power 2, and here we have to solve for the value of t. So t is the unknown we have to solve for. Okay, now you see, by mere inspection we can conclude that the value of t is equal to 2. How? You see, following this rule of indices, that if you have a raised to power b equals to a raised to power c, since they have the same base aa, simply compare the exponents such that b is equal to c. Now in this case, we have the same base tt, simply compare the exponents such that the value of t is equal to 2. Now, quite alright, this is one of the solutions of t, that t is equal to 2, but there are other solutions for the value of t. So let us solve for them. Solution, we have t raised to power t is equal to t raised to power 2. So let's first divide both sides by t raised to power 2 over t raised to power 2. This divide this, we have 1. So t raised to power t over t raised to power 2 is equal to 1. Then, following this rule of indices, that if you have a raised to power b over a raised to power c, this equals a raised to power b minus c. Applying this rule right here, what we then have is this, that we have t raised to power t, then because we have the same base, you pick 1, then you subtract the power, that will become t minus 2 is equal to 1. Then at this junction, we are going to introduce natural logarithm to both sides of the equation. So ln in bracket t raised to power t minus 2 is equal to ln 1. Okay, now don't forget that ln is equal to log 2 base e, while logarithm is log 2 base 10. So that means that we can apply the property of logarithm on natural logarithm. So following this rule of logarithm, that if you have logarithm of a raised to power b, this equals b times logarithm of a. Applying this rule right here, what we have is this, that power t minus 2 multiplied by ln t is equal to ln 1. So from here, let's then get the value of ln 1. Ln 1 is equal to 0. So inputting 0 for ln 1, we have t minus 2 multiplied by ln t is equal to 0. So from here, we have it that t minus 2 is equal to 0, or we have ln t is equal to 0. So for this first equation right here, which is t minus 2 equals 0, we have t minus 2 equals 0. Move minus 2 over to this side, the value of t is equal to 2. This was the first solution of t that we got the first time. You see right here that the value of t is equal to 2. Now, let us then solve for the other value of t from this other equation, that ln t is equal to 0. So we have ln t is equal to 0. Now to eliminate ln, we're going to introduce e to both sides of the equation. So e to the power of ln t is equal to e to the power of 0. From here, if we cancel ln, what you have is t is equal to e to the power of 0 is 1. In fact, if you have a to the power of 0, this equals 1. B to the power of 0 is equals 1. The only exception is when you have 0 to the power of 0, this is not equal to 1. All others raised to the power of 0 is equal to 1. So from here, we have two solutions for the value of t, that t equals to 2 and t equals to 1. So let us then check whether the solutions of t are the correct solution. So from here, let's check it out. Check the question, which is t raised to power t equals t raised to power 2. For the first value of t, which equals 2, so inputting the value of t as 2, 2 raised to power t is 2 equals t is 2 raised to power 2. From here, 2 power of 2 is 4, which equals 2 power of 2 is also what? 4. So this means that the value of t1 as 2 is the correct solution. Let's then confirm for the other second solution of t. So in the equation, t power of t equals t power of 2, inputting t as 1, so 1 raised to power 1 equals t is 1 raised to power 2. Now 1 raised to power 1 is 1 equals 1 raised to power 2 is also 1. So this means that the value of t2 is equal 1 is also the correct solution. So with this, we have confirmed that yes, the two solutions of t are the correct solution. So don't forget to like this video, subscribe to this channel. Thanks for watching. See you in the next video. Bye.